Polarization explains why electrically neutral bits of paper are attracted to a charged object, such as a charged comb. Molecules are polarized in the paper with the oppositely charged sides of molecules closer to the charged object. When an external negative charge is brought closer from the left, the charges within the neutral atoms or molecules rearrange. All the atoms or molecules near the surface of the isolator become electrically polarized. One side of the atom or molecule is induced to be slightly more positive or negative than the opposite side. The atom or molecule is said to be electrically polarized. Charging by induction is not restricted to conductors. Charge polarization can occur in insulators that are near a charged object. When a charged rod is brought near an insulator, there are no free electrons to migrate throughout the insulating material. Instead, there is a rearrangement of the position of charge within the atoms and molecules themselves. And the answer is charge polarization can occur in insulators that are near a charged object. And the answer is charge polarization can occur in insulators that are near a charged object. So what happens when a charged object is placed near a conducting surface? Rub an inflated balloon on your hair and it's become charged. Place the balloon against the wall and it's sucked. The charge on the balloon induces an opposite surface charge on the walls. The charge on the balloon is slightly closer to the opposite induced charge than to the charge of the same sign.
Capacitor is a basic component of electronics, a device that stores electrical energy in an electric field. The most common use for capacitors is energy storage since the late 18th century. Additional uses include power conditioning, signal coupling or decoupling, electronic noise filtering, and remote sensing. Inside the capacitor, the terminals connect to two metal plates separated by a non-conductive substance or dielectric. Capacitors are used in a wide range of industries and have become an essential part of everyday life. Insulators are materials that inhibit the flow of electrical current. The atoms found within an insulating material have electrons that are tightly bound with one another, and because of this, they do not move much in the materials. It has two attributes, the low conductivity and high resistivity. And they may protect heat, sound, and the passage of electricity. Thermal insulators, sound insulators, and electrical insulators are used to keep houses warm, protect electrical wires, and soundproofing rooms.
1 minute. Yeah, I could do this quick. So say we've got a goober, and this is a conducting material. How do we know it's a conducting material? Well, we take a look at its atoms. Wait, hang on. But to make this like a proper tutorial vid, what are you saying? What are you saying? We got the colours. Alright, so say we've got the material. That's the material. Yeah, we've got the material and it's got its atoms, right? Each it's got molecules. What the? No. The material has atoms which each have protons and neutrons. Protons are negatively charged. Sorry, positively charged. Oh, I'm waffling. Protons are positively charged while it has got its electrons around it. Protons, they don't move. The most they can do is wobble around it, right? So, we've got the negative charges on the outside of the atoms, and these electrons are allowed to move freely in between the conducting material, and that is what makes it a conductor officially. So So say we've got a charge, like from a battery or an electric field, and it's charged by induction or charged by conduction, yeah? So this goober is now negative. Let's say it's negatively charged. What the electrons tend to do is move out to the furthermost sides to try and get away from each other, because like charges repel, unlike charges attract. Electrons don't like each other very much. Neither do the neither do the protons. So the electrons try their best to get away from each other because they are races to themselves. So we get an negatively electrically charged goober, which has multiple uses, like electricity, mostly electricity, right? Yeah, electrical charge. So examples of good conductors are gold. Wait, no, I've got neat trick. Gold, silver, and copper. Copper is the most common because it's quite cheap, and it's used in our wires and in every little thing. Not every little thing, but a lot of things. So, yeah. Thank you for your time. That's it.
Coulomb's law is a law stating that like charges repel and opposite charges attract, with the force proportional to the product of the charges and inversely proportional to the square of the distance between them. Now, the formula is F equals K times Q1 times Q2 divided by D squared. In the formula, the value F is the electrical force, K is the Coulomb's law constant, which, dependent on the medium that charged objects are in, is different. Q1 is the quantity of the charge of object 1, and Q2 is the quantity of charge of object 2, and D is the distance separating the two objects. Now lastly, for the units, the electrical force is expressed in newtons, and it's a vector quantity as it has both magnitude and direction.
Alright, so I think we all know by this point some basic electrostatics things. Now we're going to do something that involves a previous part of this. Electric fields. Now what is an electric field? To put it simply, it's a field around a charge that either repels or attracts things. So let's put it in a kind of easier to explain term. So I'm pretty sure we all know how gravity works in terms of planets. They have a field around them that pulls things into it. An electric field is pretty similar to that, except instead it can either pull things in or push things out, depending on its charge. Now, the charge of it, I'm pretty sure we all know this, but it can either be a positive charge or it can be a negative charge. And those charges, they do different things. A positive charge will repel, and a negative one will attract. And they always attract towards the point of charge. Pretty simple. But how do we find that point of charge if we don't know where the point of charge is? Simple. Just use Coulomb's law. And that should be about it.
Electricity exists in the smallest particle in nature, called the atom. The atom is the basic building block of matter. So, in the atom, there are three subatomic particles: protons, neutrons, and electrons, and those are located in the nucleus of the atom. There are some electrons that are constantly moving very quickly.